Now let's look at example of this. Okay, let's go back one more time. Example of period and frequency calculation. Example 1. Device completes 20 vibrations in 28 seconds. What is the period of oscillation and the period of the frequency of oscillation? Okay. Now we look at this 20 vibration will give you, if you want to find the period, which is the time, you have to put time on top to be divided by the number of cycles. Okay, this is one of the fastest way to differentiate between the method of finding period and frequency. So 28 over 20, we use time divided by cycle. So the answer is 1.4 second. Then if you want to find the frequency, how frequent the vibration takes place in 1 second, so basically vibration, so you put vibration divided by time, so vibration should be on top. So 20 divided by 28, so the answer is 0.71 Hertz. Or you can simply use the formula F equals to 1 over T, which is giving you 0.71 Hertz. Example 2, figure shows the graph, displacement time graph. Amplitude is 7 cm. Period is not 0.03. Period must be one complete cycle. How do I define one complete cycle? It's basically this point to another point. Okay, so it seems to me there are 3 parts, so I can label them as 0.01 and 0.02. 3 parts, 0.03, so 2 parts, 0.02. I need 2 parts because that's one cycle. This is 0.01, 0.02, and this is the answer for period. Frequency, you must understand that you cannot get it from the graph, so you have to calculate using 1 over T. So you get 50 Hertz. Remember, you cannot get frequency from the graph. You have to calculate. Now, when we look at this ruler moving up and down, we can visualize it along with the graph, and it shows us the amplitude is this maximum displacement from the equilibrium level, 5 cm, as well as going down with also negative 5 cm. Now, this one amplitude is 6 cm, and that's my number if you want to contact me. And the time is 0.15, but that's not the period. So we have to analyze the graph carefully. We separate them into a few regions. It seems to me we have 1, 2, 3, 4, which is one cycle. 5, 6 is another half cycle. Okay, one cycle for 1 to 4, and 5 and 6 represent half a cycle. So 1.5 cycle is a common sense way of looking at things. 1.5 big T period equals to 0.15, so you can calculate it to be having the answer of 0.10 second. So we can look at this one more time to be more sure of how it works. Okay, we have this graph again, and you can dissect them into different pieces, and I'll call them by, the quarter pieces. So I have 1, 2, 3, 4, and 5 and 6. So 1 to 4 represents one period T, and 5 and 6 is another time of half the period. So T plus half T is 3 over T, that's equals to 0.15 second. So the period is 0.10 second. And this is how you get 3 over 2T. Lambda, displacement distance graph. How to write? Like Chinese word, you just follow. Okay. Now we also look at this one. This one is lambda. What exactly is lambda? Lambda is wavelength, and it is the distance, the horizontal one, of one complete cycle of wave, one complete oscillation or vibration. Now this one amplitude 5 cm, and the wavelength has to be 8. We don't take 12 because that's one full cycle. How about this? Distance between P and Q is 9 cm. Peak to peak is lambda. Then another one, peak to trough, or should I say crest to trough, is half a lambda. So lambda and half a lambda is 3/2 lambda. That's equals to 9 cm. So lambda, the wavelength, is actually 6 cm. Now speed of a wave can be very fast or slow. Right? So how do we get the formula for the speed of wave? Now this direction of wave propagation, we have lambda wavelength in meter. We also have period time in second. So how do we find out about the formula? Do you still remember speed is basically distance divided by time? Alright, so that's how you define. So V equals to lambda over T. Both of these represent one cycle. So they are very, very unique. Do you also remember that looking back at V equals to lambda over T, do you still remember F equals to 1 over T? So can I say lambda and bracket 1 over T represent lambda F? So because of this, I can commonly call this as V equals to F lambda. And you must memorize this. You must memorize this.